Let's go ahead and get started. So who can remember, who remembers where we stopped last time? Did you say 12? 12. And did we finish 12 or did we actually?
We finished 12.
We finished 12? Great. Thank you very much.
I did.
You are amazing. So let's do 13 now. Ready? Let's do 13 now. Ready? So
Okay, we're starting.
2x plus 4. Oh no, that's tragic.
Oh,
What happened? 2x plus 4 over x squared minus 5x plus 4 minus 2 over x minus 4, like that. So are these denominators the same already? So we're gonna have to get them to be the same. So first, in order to do that, we have to factor the first denominator. The second denominator already has x by itself, basically, so we can put parentheses around it, and that basically technically factors it. But the first one, though, what factors can that one be made into? A negative, and a negative and a positive is a negative, and a 1 and a 4 makes a 4. So 4 times 1, but what if I made them both negatives? So yeah, that would work. So that makes -5 plus it multiplies to make +4. So that's pretty sweet. So then we have 2x plus 4 all over x minus 4 times x minus 1 minus 2 over x minus 4. And what do we have to do before we can subtract them? We have to play the jealousy game, right? So what's the second fraction jealous of?
-1.
It's jealous of the x minus 1. By the way, did I tell you about the program called x minus 1? One time there's a really cool radio program called x minus 1. You should listen to it someday. It's an old time radio program from like the 1940s called x minus 1. You should look it up online, and there's a really cool episode called Star Bright. See if you can find that one. It'll help you, and it'll encourage you to be smart. Although it's kind of well, maybe I shouldn't have said that. I just realized there is one sort of slightly sinister thing in that video, in that story. It has people like travel through time, which is kind of a scary thing, but so let's go ahead and figure this one out. How do I figure this out? Well, it already has a common denominator at this point. What do I need to do at this point now that it has a common denominator? Basically, they're going to join into one team now. So we're going to make all of them be over the same single common denominator. Boom. Then what do I do on the top of it? On the top of it, I go ahead and distribute to -2. So what's -2 times x? -2x. And what's -2 times -1? +2. So make sure you distribute the negative times the negative to get a positive. And now what do we do next? Combine the like terms. So sometimes like terms actually have a fight and then they both disappear. So these just cancel each other out. Wow, that's scary. So +4 + 2, what happens to that? Because it's a negative times a negative. So what's a +4 + a 2? 6, correct. So 6 is left over x minus 4 times x minus 1. And let me check and make sure that's the final answer. Yes, it is. So that's the final solution. Any questions about that? Okay, let's try some more. Let's do 14. 14 the Great. There's two famous people in the world, Alexander the Great and 14 the Great. Just kidding. X squared minus 65 over x squared plus 15x plus 56 minus x minus 9 over x plus 7. So how does that look? So the first thing I can do, let me have fun. How about this? Is the first thing I can do, cross out this 6 with this 6, cross out this x squared with this x squared, cross out this 5 with this 5, cross out this x with this x, And then you just have negative 9 over 15x plus 7. Is that right? Just kidding. That's actually that's not mathematically possible. So I shouldn't do that. That was really bad of me. Okay, so then, but how do I do it the right way though? I have to look at the bottom of this one and factor it out. So x squared factors into x times x, and you bring the first plus sign down, and plus times plus is plus, and then 1 times 56 is 56, and then what factors of 56 will add up to be 15?
7 and 8.
Wow, smart. Wow. 7 and 8, yep, you're right. It's pretty fast. And then, by the way, why was 6 afraid of 7? Have you ever heard this joke? Why was 6 afraid of 7? Because I wasn't thinking about that. But why was 6 afraid of 7? Because 7, 8, 9. Okay. So now, so we factored out the first denominator. Now let's play the jealousy game. What does the second denominator not have? X plus 8. So it's jealous of that and it wants it, so you're going to give it to it. So now both fractions have everything in the denominator is in common. They all have the same amount of stuff. So now they're on the same team now, and so they're going to join together and start a new special neighborhood together. And the denominator is x plus 7 and x plus 8 as well. Then what goes on the top of it? It's x squared minus 65. Uh-oh. Are you good at doing triple multiplications, or do you just want to do double multiplications? So technically we have to do x times x, which is x squared, but then we have to apply a negative to it though. So is that too much to do in your brains, or can you do it? So is it okay if I write down negative x squared? And then what do we have to do next? Then we have to do x times 8, which is 8x, except you have to multiply by negative, which makes it negative 8x. So can you keep up with that? It's a little confusing. Then we have to do negative 9 times x, which is negative 9x, except you have to multiply that by a negative outside the front. So negative 9x times a negative is a positive 9x. How's that? And then what's negative 9 times positive 8? Negative 72, except you have to multiply that by a negative. So what's negative 72 times a negative? Positive 72. Right. So that was incredible. Wow.
And then you just leave.
And then you just leave, well, you leave it like that for a second, but then you combine the like terms. So are there any like terms in it? Yep. There's x squared and there's negative x squared. So cross out those. And then there's negative 8x plus 9x. What does that add up to make? That equals 1x. And then there's negative 65 plus 72. What does that make? That makes a positive 7. So it's x plus 7. And in the bottom, we have x plus 7 times x plus 8. So wait, now the top of it's not really factored, but I could factor it out by putting an invisible 1 at the front. So it's like x plus 7 can be factored into 1 times x plus 7. Now what can I do? Now I can cross out the common factors, and I can get 1 left over x plus 8, like that. Perfect. So any questions? Let me make sure that that's the right solution, because, yep, it is. Perfect. Any questions? So if you can do a problem like this, that means you're like doing really well. So you're doing really, really well. Let's try number 15. Wow. So 15 says x plus 3 over 2x plus 10 plus x over 25 minus x squared. So this is a little bit sneaky of a problem. So it has x plus 3 on the top, but 2x plus 10 can have something factored from it, so it's not factored yet. So I'm going to circle it in red. So remember that it's not ready yet because it's red. So I'm going to factor out a 2. Forgot my water bottle today. 2 comes out, and then from the second one, I can factor the second one out by doing the method of doing the square root factoring method. So 5 minus x, and then the conjugate is 5 plus x. Presto. So let me rewrite this problem again. So we've got x plus 3 over 2 parentheses x plus 5, and then we've got plus x over 5 minus x and 5 plus x. Presto. Now, which factors does the first fraction not have that it's going to be jealous of in the denominator? It does not have a 5 minus x, right? So it's jealous of that. And which factors does the second fraction not have that it's going to be jealous of? 2, correct. So it needs that one. Now I made a big mistake because when you multiply a group by another group, you have to put both groups in parentheses. So I need to put parentheses around the x plus 3. Now it's ready to go. So now it can join together into one big happy family. One big happy fraction. There we go. And then we need to distribute the top. So x times 5. Wow, makes me want to feel like giving up. Too much work. X times 5 is 5x. X times negative x is negative x squared. 3 times 5 is 15. 3 times negative x is negative 3x. And then 2 times x, that's easy. 2 times x is 2x. Now we're ready to do what? Simplify. So we're going to combine together the like terms. So we have 5 minus 3x, which is 2x, plus 2 more x. What is 5x plus minus 3x plus 2x? What does that result in? What is this plus this plus this? I think it's 4x. Did you say 4x? 5 minus 3 is 2, and then 2 plus 2 is 4. So it's gonna equal 4x. And let me put a negative x squared first. So it's negative x squared plus 4x. And then what comes last? Plus 15 over, wow, this is not my favorite one. Over that, right? So we get the final answer is negative x to the 2 over plus 4x plus 15 over 2x plus 5, 5 minus x. Any questions? Now there is something I was afraid was going to happen. Once in a while, when you have a 5 minus x in the bottom, sometimes you have an x minus 5 on the top. And then you have to like reverse it by using like a negative sign. But that didn't happen this time, so we'll keep an eye open for it in case it happens a different time. Just be aware that sometimes you have to reverse a 5 minus x and change it to an x minus 5 by putting a negative in front of it. But we didn't have to do that this time, though. Are you ready for 16? So we can call 16, let's think of a name for each problem. So 16 can be sweet 16. Sweet 16, like going to the sweet 16. By the way, do they have the sweet 16 in the NAIA? Probably. Did our football team go to the sweet 16 last year? Maybe. Or maybe the sweet 20 or something. 5x over x minus 3 plus 90 over x squared minus 9 minus 5x over x plus 3, right? So let's do the factoring first. Which one of those is already factored? The last one's also factored already, but the middle one's not. So I'm going to switch to red so we can remember to do that one. So what does x squared minus 9 factor apart into? X minus 3 and x plus 3, correct. And therefore, what is the first fraction going to be jealous of that it does not have? I'm going to switch to green actually, because there we go. The first fraction in its denominator, the denominator is like what kind of things it has. It has an x minus 3, but it does not have what? It does not have an x plus 3, so it's jealous of that. Are you jealous of anything that anybody else has, by the way? So technically, you're like a math problem. And then the last fraction, what's it jealous of? It has an x plus 3, but it does not have an x minus 3. If everybody could just be happy with what they had, then they wouldn't even worry about what they didn't have, maybe. I'm not sure. Unless it's like food and water. You need that, of course. So everything now has a common denominator, so it's going to join together into one big happy family, or a big happy fraction for short. There we go. So everything's going to have an x minus 3 and x plus 3, and bottom and on the top, you're just going to have one big thing on top. So what's going to be on top? Well, on the top, you'll have 5x times x. What's 5x times x? 5x squared. And then you'll have 5x times 3. What's 5x times 3? 15x plus 90. Then you have, now this is also sort of a triple multiplication, because you have 5x times x, which is 5x squared, but then it's negative of that, though. So it's actually negative 5x squared. Negative 5x squared. Then you have 5x times negative 3, which is negative 15x. But you have to remember that you have this negative in front of that, though. So if you apply that negative, it's going to be positive 15x. So don't forget to distribute the negative after multiplying. So we're done with the top. Is there any other steps? Are there any other steps we can do? Yep. So does anything cancel out completely? Yeah. Oh, wait, actually, hold on. Sorry. 5x squared can cancel out first, and then the 15x plus 15x cannot cancel, can add together to be 30x, and then the plus 90. And then I think you're right, though, that later on, something could happen. It's never happened before, but it could still happen. What happens if the top of it factors out, though? Then you have to go further. So does the 30x plus 90 have anything that can factor out from it? How about 30? Because 30 goes into 90. So that's not done yet. So we need to factor 30 out from it. What's 30 times what equals 90? 30 times what is 90? 3, right? Oh, wait, that reminds me. Maybe I wrote it down wrong. Hold on. Where did you see the negative 5?
Negative 5x. So 5x squared, x cancel the negative 5x, but the x isn't the thing that's negative. It's the 3, so the negative 15 is what cancels out.
Hold on. Are you pointing? Let me use a laser pointer real quick. Are you talking about that one? This one right here? And that one? Well, I think it's because you have a positive 5x squared and a negative 5x squared, but I could be wrong. Let me look at the final answer and see if I'm on the right track. Well, because I had negative 5x, positive 5x times x, that's 5x squared right here at the top. But then this negative is in front of it. So that made it be negative. You're welcome. No problem. I sometimes make a mistake though, so I'm just double checking. Okay, so I think I'm still on the right track so far. And then, but look in the bottom that we still have x minus 3 times x plus 3 in the bottom, right? Like that. So there's that. So we have x plus 3 and x plus 3 in the bottom. And then cross this out. How does that look to you? So the final answer is only going to be very simple, 30 over x minus 3. Pretty sweet. So did you realize that we took the huge problem and we simplified it all the way down to just two small things, 30 divided by x minus 3. Is that pretty cool? So that was pretty cool. By the way, let me ask, does anybody think this would matter in real life or not? Well, let me give you a scenario, see if this makes sense. What if you had to order coffee each morning for your for your office or for your like house or whatever? And let's just say that you could use this formula in blue. So remember the formula in blue? You could use the formula in blue to order coffee with every morning, but you'd have to spend like 5 minutes working through that formula every single day, plugging in and let's say X was how many people wanted coffee. You had to like plug X into it, calculate the money that you'd need to spend or whatever. Or if you knew algebra, you could just simplify that once, like on day number 1, you could simplify the whole formula and just use this. Then if you wanted to order coffee for your work, let's say that you had like 13 people to order coffee for, you could plug 13 in, get 30 over 13 minus 3, which is 10. 30 divided by 10 is 3, so you could order like 3 cartons of coffee. So which would be easier, to plug 13 into the bottom fraction or to plug 13 into the top? The bottom would be way easier, right? So actually, algebra can help your life be easier, assuming that you have to plug something into a formula. It all depends on that. So the moral of the story is don't get a job where you have to plug something into a formula, unless you want to. So let's look at 17. So 2 plus 1 over x, and then 7 minus 1 over x. Wow, okay, we finally got to something new and something more exciting and cool. Are you glad that we're not doing the same tedious problems again and again? So before I do this question, though, this question has letters in it. Let's do one without letters, because letters are a little bit harder to understand. So let me give you one with no letters. What if we had 2 plus 1/3 over 5 minus 1/4? Is that too big or too small? I guess it's not too bad. So how would we break this down if we had something like 2 plus 1/3 over 5 minus 1/4? First of all, we'd look at these little denominators, those little ones, like those, for example. So what's the common denominator of 3 and 4? What's the smallest number that 3 goes into and 4 goes into? 12. So 12, the common denominator is like the kryptonite of fractions. So remember that. The common, yes, the common denominator is x. That's right, you're right. So the common denominator of fractions is like their kryptonite. If you multiply the top of the big fraction and the bottom of the big fraction by the common denominator, then it's going to distribute to each of the little fractions. And that's going to eliminate the fractions. So what is 12 times 2? And then watch this. What's 12 times 1? And then go to the bottom side. What's 12 times 5? 60, I think. And what's 12 times -1? That's -12 over 4, right? Now, the reason I said it's kryptonite is because once you multiply a fraction by the common denominator, notice that we only had to multiply the quantity times 12. The bottom did not change. Why did the bottom not change? Because this is technically 12 over 1. So there's like an invisible 1 in the bottom, and 1 times 3 is still 3. So far it looks worse, not better. But guess what though? 12 is the kryptonite of the 3 because 3 goes into the 12 and it gets rid of the 3. So how many times does 3 go into 12? 4 times. So we're just left with 24 plus 4. How many times does 4 go into 12? 3. So we're just left with 60 minus 3. And what's 24 plus 4? 28. What's 60 minus 3? 57. And I don't think that those have any numbers in common at this point. I don't believe so. So that's the solution. So let's use the same strategy on this. So somebody already mentioned that the LCD of the top problem is x. So we're going to multiply the top times x divided by x. If I multiply, what do you get if you do x times 2? You get 2x. What if you have 1 over x times x? You get 1x over x, right? And then what do you do if you distribute the x to the bottom? You get x times 7, that's 7x minus, then you get 1x over x. Pretty cool. But then what happens when you have x divided by x? it can be canceled out. So that x cancels and that x cancels. So the result is just 2x plus 1 over 7x minus 1. And then we're done because 7x minus 1 doesn't factor out any further because nothing can factor out from it. And the same thing for the 2x plus 1. So you actually solve these fractions by getting the LCD of the smallest parts of the fractions, like the little denominators in the fractions. So let's do 18. Whoa, that one looks terrible. Okay, I'm not a very encouraging person. That's all right. 4 divided by x, it makes you get like vertigo or something because it's like flipping over back and forth. 4 over x plus x over 4 divided by x over 4 minus 4 over x. Wow, sounds like a limerick or something. How do I solve that? Well, first of all, look at the denominators. Look at those little denominators. What's the common denominator of those little denominators? 4x, you're right. 4x. So that means the kryptonite of all those fractions is going to be 4x. Now, rather than doing it as like 2 steps at once, I'm just going to assume that you know that if I multiply the top and the bottom by 4x, I'm just going to assume that you know that they would distribute to both of these, right? So we're going to take the top and the bottom both times 4x, and what does that make happen? That just means that you're going to, let me erase those purple lines and get rid of that. All that means is that you're going to have that one times 4x like that, and that one times 4x like that one times 4x, and that one times 4x. So let me stop a moment to make sure that makes sense to everybody. So if I just skipped the step of writing down the 4x to the right side, and if I jumped one step ahead to the point of distributing the 4x to every single term, then that's how you get. Does that make sense? So you can feel free to skip that step and you don't really have to write the 4x to the right side because that's just basically just taking an extra second out of your life that you'll never get back. So go ahead and just distribute the LCD to all the terms. And now you can keep going. So, but we're also going to skip one more step as well because I just feel like I'm in a good mood about skipping things today. Instead of just multiplying 4 times 4x and getting 16x, that's just a waste of time because I already know that I can cancel something out. So instead of waiting to the end to cancel it out, let's cancel it out right now. Does anybody notice that what I can cancel out? How about that? If you divide by an x and you multiply by an x, those can cancel, right? So this x right here on the bottom can cancel out that x, and this 4 right here can cancel out that 4, and this 4 right here can cancel out that 4, and this x right here can cancel out that x, right? So does that make sense to you all? So we're basically canceling before we multiply instead of canceling after we multiply. So let me stop for a second. I should have taught you this way before I even did the first one, but the first one was easy, so we had enough space to like do it all with the first one. But so sometimes if you do a big bad problem, you have to like desperate days require desperate measures sometimes. So did that make sense to everybody? So I'm still multiplying everything by the LCD, except before multiplying though, I'm canceling things out. Oh, now I'm ready to multiply. So I have 4 times 4 left over plus x times x plus x times x minus 4 times 4. Right? So what's the result of that? What's the result of that? What's 4 times 4 on the top? 16, so I get 16 plus x squared. And in the bottom, I get x squared minus 16. Now it says to type your answer in factored form, unfortunately. That they're just being mean. So we have to factor one of those. Who remembers whether you can factor the sum of 2 squares, meaning a plus between them, or whether you can factor the difference of 2 squares? Yep, that's right. So it's the bottom one that you can factor, but not the top. So the bottom one can factor out into not x squared, my fault, sorry. X minus 4 and times x plus 4, but the top one cannot. But there is one thing you can do to the top. Instead of writing a 16 plus x squared, that's kind of weird. It's more traditional to write the x squared first. So say x squared plus 16 like that. So that's the solution to that one. So it actually, I guess I shouldn't have said it was that bad. Because when you do that more efficiently by canceling things before you multiply them, then it does not take very long. So any questions about that? Here's ready to do another one kind of like that, a little. Let's try number 19. Are you ready? Let's try number 19. So number 19, because eventually you'll be past this point in your life and then you can be joyful for the rest of your lives. So if you're ever having a bad day when you're like older, just remember that you're past this, that you got through these problems at least. Sorry, hold on. 3 over w plus 8 over x. Has anybody ever had a public speaking class, by the way? Have you ever like had to give a speech?
Yeah.
So you're like, now that you're over with that, like now you don't ever have to be scared again of anything, right? That's amazing of you. Smart. 3 over w plus 8 over x over 8 over w minus 3 over x. So look carefully at those little denominators, the ones that are within the smaller fractions. What's the LCD of all that? W and x, right? Because remember you play the jealousy game and or XW for short, I guess. Wait, should it be WX or XW?
WX.
WX, yeah, I guess that's alphabetical order. So WX. Because if it has a W, it has an X, then it has everything that anybody else has. So I'm going to do, so instead of putting the WX over the WX off to this, hold on, somebody's trying to call me, some mean person. Oh, there we go, push decline. Every time somebody calls me, that means I have to disconnect the audio. Perfect, okay. WX, so I'm going to put every single term, I'm circling the term so that you can keep track. What do I do? What do I multiply all 4 of those terms by? WX. Correct. Perfect. And then we're going to cross out now we're ready to cross out the common terms in the bottom and not common terms, common factors in the bottom and the top. Are there any common factors in the bottom and top? I'm going to use orange. There we go. Oops, I made a mistake. The W has to cross out the W. Then the X has to cross out the X. Then the W has to cross out the W. Then the X has to cross out the X. So the only thing left is 3 times X plus 8 times, whoops. I keep hitting my parentheses in the wrong spots. By the way, if a leopard didn't have its spots, would it still be a leopard? 8 times X minus 3 times W. There we go. So 3 times X plus 8 times W over 8 times X minus 3 times W. Now actually, let's multiply it. So 3x is 3x plus 8w over 8x minus 3w. Is there anything that can be factored out of either one of those? No, because 3 and 8 don't come out from each other, and also x and w don't have any squares on them, so we can't really factor anything out. So that's it. Yeah. There we go. By the way, is this orange? Orange, gold. So 18, 19, 20. What comes after 19 is 20. Wow, another one like this. So 20. Ready? 20, it says that you have 1 over x plus 5 minus 1 over x divided by 5. Now we have to be careful about this one to interpret it right. The only small denominators are this one. I'm going to put parentheses around them. And that one. The 5 is not actually a small denominator. In fact, the 5 doesn't have any denominator. Like the 5 is just like over 1. So the 5 doesn't really have a denominator. So the only two denominators that you really have to pay attention to are just the top two. So I'm going to erase that 1. It is there, but you don't need it there though. I just wanted you to be aware that there isn't any denominator under the 5. So what's the common denominator therefore of those two red denominators? What's the LCD of them? It has to have one of each of them because remember it's jealous of whatever it doesn't have. So it needs to have an x plus 5 and it also needs to have an x, right? So then we're going to take every term. So I'm going to circle the terms. That's a term, that's a term, and that's a term. Every single term on the bottom and on the top, just to be fair, every single term has to get multiplied by the LCD, which is x plus 5 times x. So x plus 5 times x, and then x plus 5 times x. So remember this is an important fact to remember. Even though it did not have any denominator of its own, the 5 is still a term. So therefore you have to multiply every term on the top and bottom by the LCD. So just remember to multiply the 5 by the LCD. So then we need to cancel before multiplying. So what factors cancel out from the tops and bottoms of those small fractions? The x plus 5 cancels out, right? And the x cancels out, the x. And the 5s, wait, the 5s cancel out. No, those are multiplied, sorry, but that's a good idea though. So the only thing left is going to be 1 times x minus 1 times x plus 5. And now the bottom, well, this is going to be terrible. Hopefully it says we can keep the bottom in factored form. Yes, it does. So we actually don't have to multiply the bottom together because the bottom is already in factored form. So just keep it as is. But we have to distribute the top. So what's 1 times x? It's just x. What's negative 1 times x? Negative x. What's negative times 5? It's negative 5. Divided by, and don't multiply the bottom because the bottom needs to be in factored form. But we still have to keep simplifying the top. This is so boring. X minus x eliminates. Oh, wait a second though. I want to cancel the 5s out. Wait, you probably were thinking ahead so far, right? Yeah, I think you were thinking ahead. But I do want to cancel the 5s out now, like you said. But I can't cancel them out because that one's negative and that one's positive. So this is okay. We finally got to an example where something has the wrong sign. How do you cancel something out if it's the same number but the wrong sign? I'll teach you a trick. So right now we have this problem and we cannot cancel the 5 from the bottom and top because the top 5 is negative 5. That's not the same as 5. But what if I did this though? What if I factored out the negative 5 by taking the negative to the outside, which would be a negative 1, like that. So what if I factored from the negative 5, I factored out a negative 1, that left me with a positive 5. Because positive 5 times negative 1 is another way of writing negative 5. Now, I do have a factor of 5 that's positive, and so therefore I'm positive I can factor out the positive 5 factor in the bottom. So therefore the final solution is negative 1. And I think I mentioned this to you a few minutes ago, that when you have something that's the same but the opposite sign, basically what happens is you get an extra negative 1 left over. So the numbers can still cross each other out, but there's like an extra negative 1 that's left over. So that's all for that one. I'll let you stop and think about that for a little bit. By the way, great behavior. It's very quiet and very, very good. Maybe I should do a quick check and make sure, maybe it's too quiet. Oh, your computer's dead. Okay, that's all right. Let me do a quick check and make sure that people are not like secretly looking at like YouTube videos and something.
What are you doing?
I can charge. Basically, just, yeah.
Well, good job. I feel well, good job except for you. Except for you. But I thought with all the heads up, like you had like 20 seconds to react. I thought maybe people would have time to stop looking at whatever they were looking at. Okay, so there we go. Yeah, let's see. So 21. Let's try to do 21. Okay, 21. 5 over x plus 2 minus 5 over x minus 2. Wait, am I doing the wrong one?
No, you're doing.
Okay, good. 5 over x plus 2 minus 5 over x minus 2 divided by 3 over x squared minus 4. So this is the first one with the big fractions and the little fractions combined together, where one of the little fractions does not have its denominator fully factored out. So the one that I circled in red, that one is not factored out yet. But this one up at the top, that one is factored. That one is factored as well. So I need to factor before I can continue. That's why factoring is so important. You have to do it first before you can go on to the next step. So who knows what x squared minus 4 can factor into? What can it factor into? X minus 2 times plus 2, right? So, okay, good job. More people are watching now. Well, some people are not. Okay, so x minus 2 times x plus 2, that's what it factors into. So basically that means that the problem really is equal to 5 over x plus 2. You don't really have to write it all again though, but I'm doing it so you can see. 3 over x minus 2 times x plus 2. Okay, I wrote it all again. Now, what's the LCD? What's the LCD of those little fractions? Yep, the LCD, you're right. So according to the jealousy game, the LCD is going to be x minus 2 times x plus 2, right? So I'm going to circle each of those so you can see for sure which ones I'm talking about. Those are the 3 terms in the problem. And I'm going to multiply every term in the problem by the LCD. X minus 2 and x plus 2, and also by x minus 2 and x plus 2, and also by x minus 2 and x plus 2. Now this looks like a nightmare, but guess what? There's actually something exciting. I've learned from experience that sometimes the ones that look the worst at the beginning look the best at the end. Like, you ever known somebody who seemed like they were like really terrible at first, but they're actually like the best? So it's the same way with this problem. So get ready. First, we need to cancel things out. So what cancels out of the first fraction? The x plus 2 cancels out with the x plus 2. What cancels out of the second fraction? The x minus 2 cancels out the x minus 2. What cancels out of the third fraction? Both, yes. I love that. Now, you get x minus 2 times 5 minus parentheses 5 times x plus 2. But there's only a 3 in the bottom, so that's good. Now we have to distribute to 5. So 5 times x is 5x. By the way, I've got a question. Does anybody ever usually have time to like go to office hours on Wednesday at noon? Is that ever a good time for anybody? Because I'm wondering if maybe I should permanently just switch that office hour so that I can go to the FCA meeting on Wednesdays at noon. Because I think so far I still have not had anybody ever go to my office during that hour. So maybe I should just switch it to a different hour. But anyway, so 5 times x minus 10 is what's left. 5 times x minus 10. And then negative 5 times x is negative 5x. Negative 5 times positive 2 is what? Negative 10. Then it's all divided by 3. And now one more thing cancels out. This is amazing. 5x minus 5x cancels out. And then you have minus 10, which is negative 20. So the solution is negative 20 divided by 3. And that's the final solution because 3 does not reduce from 20. So it's just negative 23rd. So wasn't that a pretty easy answer? So a pretty easy answer to a pretty big problem. Okay, well, I guess that we can stop today, even though we have 3 more minutes of time wasted. But that way you can get ahead in the line.
It's okay.
So- You're welcome. If you walked in late, make sure that you let me know so that I can count you for attendance in case I missed you.